Hello everyone, classmates and teacher. We are team number 1 and today we are going to talk about statistical analysis applied to quality and quality tools. We are very excited to share with you the results of our research. So let's start. First, we are going to start talking about statistical analysis applied to quality. This is applied mainly on the industry, administration, or in services processes. The purpose is to serve with the required demands. It is important because it improves the quality of the products or services studied through the application of statistical tools. But now, what are quality tools? Haruo Ishikawa said that quality tools are the set of statistical methodologies. There are some important quality tools, and the first is cause and effect diagram. It is a graphical representation that shows the qualitative and hypothetical relationship of some factors that may contribute to a particular effect. The importance of this tool is that before trying to find solutions to a problem or propose alternatives for the continuous improvement of a process, it is necessary to question and identify the possible causes of the problem. There are 4 types or modalities that the cause-effect diagram can acquire, depending on the criteria for classifying the causes. The first is 6M. It is the most common. They can be identified in any process of an organization, and they are: number 1, method; number 2, manpower; number 3, materials; number 4, machinery; number 5, measurement; and number 6, mother nature. The second one is process flow method. This method establishes that it must contain a main line that follows the sequence of the activities of a process, while the causes are added according to the corresponding order of the intrinsic process. The next one is a stratification method. Stratification is defined as the act of sorting data, people, and objects into distinct groups or layers. It is a technique used in combination with other data analysis tools. And finally, we can find the most common steps to elaborate one diagram of cause and effect. Step 1 is define and delimit the problem. Step 2 is decide which diagram to use. Number 3 is search for possible causes through brainstorming. Number 4 is order causes in categories. Step number 5 is represent causes in the diagram. Step number 6 is decide which cause is most important. Step 7 is decide on which causes to act. And finally, step 8, prepare a plan. Other quality tool is the check sheet. It's a structured prepared form for collecting and analyze data. We can use it in different situations. For example, when data can be observed and collected repeatedly by the same person or at the same location. Even we can use it when collecting data on the frequency or patterns of events, problems, defects, defect location, defect causes, or similar issues. The steps to create one are the following. First is to decide the problem. Next, decide the data. Then design the form. And finally, test the check sheet for a short trial period to be sure it collects the appropriate data and is easy to use. The next quality tool is control chart. It is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a central line for the average, and an upper line for the upper control limit, and a lower line for the lower control limit. And in what moments we have to use this tool? We can use it to ongoing processes, the expected range of outcomes from a process, or in determining whether your quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. The basic procedure is: Step 1. Choose the appropriate control chart for your data. Step 2. Determine the appropriate time for collecting and plotting data. Step 3. Collect data. Construct your chart and analyze the data. Step 4. Look for out-of-control signals. When one is identified, mark it on the chart and investigate the cause. Step 5. Continue the plot data as they are generated. As each new data point is plotted, check for new out-of-control signals. These are one of the most common signals out of control. A single point outside the control limits. 2 out of 3 successive points are on the same side of the center line and farther than 2 from it. A run of 8 in a row are on the same side of the center line. The next quality tool is flowchart. It is a graphic representation made by means of a set of shapes or symbols to precisely identify the steps or activities to be followed in a process. The steps to do a good flowchart are the following. The first step is define the objective of the problem. Then, delimit the process under study. Step 3. Make a general draft of the process. Step 4. Highlight decision points or bifurcation points. Step 5. Review the complete diagram. The last step is to analyze the final flowchart. This tool has advantages, like identifying the various activities and resources that are part of the process. It is possible to locate opportunities to improvement. The next quality tool is histogram. This is the most used graph to show frequency distributions and is helpful to identify the defects that cause most deviations. Histograms are very useful and we can use it in different situations, like when our data is in numbers, determining whether the outputs of 2 or more processes are different, and when you wish to communicate the distribution of data quickly and easily to others. The steps to create histograms are: Step 1. Collect at least 50 consecutive data points from a process. Step 2. Use a histogram worksheet to set up the histogram. Step 3. Draw X and Y axes on graph paper. Mark and label the Y axis for counting data values. Step 4. For each data point, mark off one cone above the appropriate bar with an X. Also, there are different shapes of histograms. One of them is normal distribution. It's a common pattern is the bell-shaped curve known as the normal distribution. The next is skew distribution. The skew distribution is asymmetrical because a natural limit prevents outcomes on one side. Comb distribution. In a comb distribution, the bars are alternately tall and short. Then we have truncate or haircut distribution. The truncate distribution looks like a normal distribution with the tails cut off. And the last one is duck-foot distribution. The duck-foot distribution is missing something. Results near the average. The next quality tool is Pareto diagram. They allow to find the defects that cause most of the deviations. This tool can help us to analyze data about the frequency of problems or causes in a process. When there are many problems or causes and you want to focus on the most significant and communicate with others about the data. The next quality tool is scatter diagram. This diagram analyzes the relationship and behavior of one variable against another. The scatter diagram is useful when you have paired numerical data, when your dependent variable may have multiple values for each value of your independent variable, and when you are trying to determine whether the two variables are related. Finally, we have Gantt chart. This will allow us to analyze the activities that are carried out in relation to the time in which they will be carried out. This is an easy tool and has good advantages, like it is a simple tool to perform. It is also quick to do. Show us a project from a visual perspective. Supports interconnect activities. Combine tasks in a systematic way. And workload estimation. This was our Team 1 video. We hope you like it and thanks for watching.